We meet again. So we're going to continue with some integration by parts. So let's do the integral from 1 to 4 e to the square root of x dx. So at first it does not look like integration by parts. Let's do a substitution. We say, well, let's let u be, no, let's not call it u because we're going to do integration by parts. Let's call it s equals square root of x. Okay. Again, this is that square root. So square root of x, the derivative is 1 over 2 square root of x dx. Okay. So when we put this through the substitution, let's put this through the substitution, we get the integral. When x equals 1, s equals 1. When x equals 4, s equals 2. Okay, so we're going to have e to the s, and then dx is going to be 2 square roots of x ds. But square root of x is, look at that, that's s. Okay. So we get 2, the integral from 1 to 2, s e to the s ds. Now, this is a polynomial times a transcendental. So remember, when you have a polynomial times a transcendental, your u is going to be the polynomial. So u equals s. See, that's why I didn't want to use u, because then I'd be doing u equals u, and we'd have an identity crisis, right? Okay. dv is e to the s ds. du is ds, and then v is e to the s. Okay. So we're going to have 2 uv, so that's going to be s e to the s. I'm going to have 1 and 2 there. Those are my limits. Minus the integral v du. Okay, well, this is easy enough. 2 times, now it's going to be 2e squared minus e minus integral of e to the s is e to the s. So that's going to be 2e squared minus e squared plus e. These are going to cancel, so we're going to get what? 6. No. 2e squared. Okay. I hope that's what I got last time I did this problem. Yep. Okay. All right. Next, we're going to get into what are called reduction formulas. Okay. So let's look at these reduction formulas. Okay. So these are actually in the book, okay, as a problem. But we're going to go ahead. I'm going to go ahead and show you how one of them is done. Okay. So we're going to do the nth power of sine of x dx, okay, equals, let me actually look this up in the book, make sure I have it written right because I'm taking it from my notes. Okay, this is number 33. I'll probably have you guys do the other one. So this is an example 6. It's actually an example. Nth power sine of x equals -1 over n cosine x sine to the n minus 1x plus n minus 1 over n sine to the n minus 2x dx. Okay, so we're going to go ahead and derive that. Okay, so the first thing we're going to do is, because we have this sine to the n minus 1 here, you sort of get the idea, okay, let's write this as the integral sine to the n minus 1x times sine of x dx. Okay, so now in this case, we're going to let this be u. Why? Because we can take the integral of sine of x, but we have a harder time taking the integral of sine of x to the n minus 1. Okay, so u is sine of x. I just totally messed that up. U is sine of x to the n minus 1. dv is sine x dx. du is n minus 1 sine of x to the n minus 2 times derivative of sine is cosine of x. Now v, the integral of sine, is negative cosine of x. Okay, so uv minus v du. Okay, so this is going to equal negative cosine x sine of x to the n minus 1. You can see that here, except for the fact that there's this 1 over n. We'll deal with that in a minute. Okay, minus the integral of v du. V du, so that's going to change the sign to positive. N minus 1 sine n minus 2 of x. And now we're going to have cosine squared of x dx. Okay, now here we're going to have to do something tricky. We're going to realize, wait a second, cosine squared of x, that's 1 minus sine squared of x, right? So let's actually, before we go any further, let's do a little trick. We're going to name our integral I. That's going to help us sometimes. And this is going to help us here. So this is I equals this thing. Okay. I'm sorry, I should have put that earlier, but oh well. Now, what we're going to do is we're going to replace cosine squared of x is 1 minus sine squared of x. Okay, so when we make that replacement, watch what happens. I, which remember is this thing, equals, move this up a little bit, there we go, negative cosine x sine of x to the n minus 1 plus, let me pull that n minus 1 out, okay, the integral sine to the n minus 2 of x times 1 minus sine squared of x. Okay, let's do a little bit more algebra. We're going to multiply this out. So we're going to get I equals negative cosine x sine n minus 1x plus n minus 1 times, let me do the first one's going to be the integral sine of x to the n minus 2, okay, dx, because I'm going to split this up, okay, minus the integral sine to the n of x dx, or sine of x to the n. So what I'm doing here, taking something to the power n minus 2 times to the power 2, so that n minus 2 and 2 add to give us back n. But look at that. This thing is I. Nice little trick here. So we have I equals negative cosine x sine n minus 1 of x plus n minus 1, the integral sine of x to the n minus 2 minus n minus 1 times I. Okay, so now we're going to go ahead, we're going to add this to the other side. Okay, so I sort of just write this, but let me do this. 1 plus n minus 1 times I is going to be n times I. So we're going to get n times our integral equals negative cosine x sine of x to the n minus 1 plus n minus 1, the integral sine of x to the n minus 2 dx. So let me make a little more space so that I can keep this all on one page. I, remember, is this thing. We're going to divide everything through by that n. And that is our reduction formula. Ta-da, ta-da, ta-da. Okay, all right, see y'all in the next video.